expected to have any more sunspots or CMAs that are important. Trouble is, the foreseeable future in space weather forecast is, at most, just a few days. We still don't know a lot about CMAs, like where they're going, how big they are, or when they might happen in the future. 2 new solar probes will get closer to the sun than any other spacecraft is. Flares and coronal mass ejections on the sun's surface are related to the solar wind. Solar orbiter success will be very important for our understanding of how the sun works. We think that the sun's magnetic field is made in a way similar to how Earth's is, but it is much more dynamic and changes all the time. We have an 11-year sunspot cycle, during which the sun's magnetic fields move towards the poles and the polarity changes. On top of that, the magnetic field goes up. Solar orbiter will measure these magnetic fields for the first time, and it will also give us the chance to watch the magnetic fields move to the sun's poles. To do this, solar orbiter will take pictures of the sun's atmosphere and measure the number, speed, and temperature of the particles moving across the space between the sun and Earth. But the magnetometer, which is made to measure the tiny magnetic fields in space that are carried by the solar wind, could be one of the most important and sensitive instruments. However, the trajectory of its future is a subject of inquiry for scientists who are peering into the vastness of space for answers. These scientists, akin to contemporary prophets, foretell a potentially apocalyptic fate for our sun. The implications are astounding. The Earth's surface temperature is projected to reach levels capable of melting rock, and indeed, the entire planetary surface. Scientists are aware that at some point in the future, the sun will undergo fundamental changes that will impact the planets in our solar system. Stars, some are referred to as solar twins due to their striking similarities to our sun. The study of solar twins is crucial, not only for comprehending the sun itself, but also for gaining insights into the future of our solar system. Korat bears a resemblance to the sun in terms of both mass and other characteristics. However, astronomers made a noteworthy discovery. Korat Sol 1 exhibited a lower concentration of lithium, a key element that facilitated an accurate determination of its age. It turned out that this star is slightly older than the sun by a few billion years. By observing stars older than our sun, scientists can glean valuable information about the sun's future trajectory. As the sun ages, it will undergo a significant increase in brightness. This heightened luminosity is a result of an ongoing internal transformation within the sun, where 2 opposing forces engage in a constant struggle. These forces sun. This pressure is generated by the process of nuclear fusion, where hydrogen is converted into helium. The sun has sustained this fusion process for billions of years, marking its enduring battle against gravity. The sun's life is essentially a perpetual conflict between gravitational forces attempting to compress the star and the outward thermal pressure exerted by the gas. The delicate equilibrium between these forces has kept the sun stable for 4.5 billion years. However, with the passage of time, this balance is gradually shifting. As the sun continues to fuse hydrogen, it produces an astonishing 600 million tons of helium every second. The alteration in density has a profound impact on nuclear reactions. As the core becomes denser, the rate of hydrogen burning increases, akin to turning up the burners. This translates to an escalation in the energy emanating from the core. Consequently, our sun is becoming 10% brighter with each passing billion years. As it ages, the solar system experiences a rise in temperature. Scientists are aware that this ongoing process will eventually lead to significant consequences. The habitable zone, where Earth resides. This region orbits a band around the sun and is characterized as the habitable zone because it maintains the ideal temperature for liquid water. This unique condition makes Earth the sole planet in the solar system where life can thrive. However, as the sun intensifies its power, the habitable zone will undergo a shift. To glimpse Earth's potential fate 2 billion years from now, astrobiologist Professor Lynn Rothschild suggests looking to Venus. Venus is visible in the sky, positioned as the brightest object following the sun and the moon. Venus and Earth share a common origin, composed of similar materials and roughly the same size. The key distinction lies in Venus's proximity to the sun, resulting in its higher temperature compared to Earth. Interestingly, despite being farther from the sun, Venus is even hotter than Mercury. In 2006, the Venus Express probe was launched to study Venus's atmosphere in unprecedented detail. Analysis revealed a crucial clue among the clouds regarding Venus's elevated temperature. The Venus Express provided insights by detecting a significant amount of deuterium, a heavy form of hydrogen, indicating the presence of water in the planet's past. It became evident that Venus was once a drastically different world, resembling a beautiful water world not unlike Earth today. There existed liquid water, reasonable atmospheric pressure, and organic compounds on Venus in the past. The available evidence strongly suggests that Venus was once situated in a habitable zone, making it a plausible environment for life. Approximately 3 billion years ago, as the sun's luminosity increased, it had a terrible impact on Venus's water. The rising temperature of the sun had a cascading effect on Venus. As the sun's heat intensified, the surface of Venus heated up, causing the water to transform into steam. Since steam is a greenhouse gas, it possesses the capability to trap solar radiation. Consequently, akin to a greenhouse, the temperature on Venus started escalating continuously. It appears that a runaway greenhouse effect played a pivotal role in making Venus the hottest planet in our solar system. While Mercury is closer to the sun, it lacks both an atmosphere and water. In contrast, Earth possesses both of these essential elements. As the sun becomes brighter and evaporates our oceans, the impact on Earth is expected to be significantly more severe than the currently observed effects of human-induced global warming. Over the course of the next 2 billion years, Earth's temperatures are set to soar, presenting a stark challenge for life to either adapt or face extinction. Approximately half a billion years from now, some regions could experience temperature increases of up to 20 degrees. This climatic shift will drive a profound evolution in life as we currently understand it. Similar to the way present-day animals adapt to survive harsh winters, future generations may employ comparable strategies to endure scorching summers. Consider a bear accustomed to hibernating in winter. A future scenario could reverse this pattern, with animals opting to hibernate during the scorching summers and remaining active in the cooler winters. Grasses may adapt by setting seeds in spring, ensuring the survival of the plant through the harsh summer, germinating when autumn rains return, and flourishing in the winter. In less than a billion years, the greenhouse effect is anticipated to intensify, causing temperatures to escalate dramatically. As the land becomes hotter, even winters may become inhospitable for most organisms. Warm-blooded large animals like bison, unable to adequately cool down in the increasing heat, may face extinction. In just over a billion years, the once thriving land could transform into a barren desert devoid of life. The atmosphere will heat up more rapidly than the water, leading me to predict that, similar to the ancestors of dolphins, the descendants of bison may need to transition from land to water for survival. Projections indicate that in 2 billion years, even the water will have disappeared. As it evaporates, Earth will increasingly resemble present-day Venus. In less than 3 billion years, the prevailing belief is that the scorching sun, combined with a runaway greenhouse effect, will likely eradicate nearly all life on Earth. But intelligent life may just find a way out. What sets us apart from other organisms is our possession of technology. This advantage may provide us with the option to migrate to other planets as Earth becomes inhospitable. As Earth heats up beyond tolerance, Mars could become a more viable habitat. The potential for life on Mars is uncertain, but with our technological capabilities, it's a possibility. Who knows? I have great faith in our descendants. Imagine for a moment that 93 million miles away, a powerful force is brewing, a force so intense that it has the potential to disrupt your daily life in ways you wouldn't expect. I'm talking about our very own sun, currently experiencing one of the most turbulent and awe-inspiring phases of its life cycle, the solar maximum. Right now, the sun is buzzing with activity, and its effects are being felt across the universe and even here on Earth. Why should you care? You might wonder, what does this fiery giant have to do with me? Well, a lot more than you think. The sun's increased activity during the solar maximum doesn't just lead to beautiful auroras in the night sky. It can disrupt power grids, scramble your GPS, and interfere with radio communications. It's like an invisible storm raging across the cosmos, and it's influencing the technology we rely on every day. But to really grasp what's happening right now, we need to talk about the sun's 11-year cycle. Think of it as the sun's natural rhythm. It goes from quiet to chaotic and back again over a period of 11 years. At the start of the cycle, things are calm. Fewer sunspots, fewer flares. But as we approach the solar maximum, all that changes. The sun becomes much more active, its surface crawling with sunspots, and bursts of energy explode in the form of solar flares. This is where we find ourselves now, right in the middle of this intense phase. Scientists from NASA and NOAA have confirmed that the sun is reaching its peak, and this solar maximum will continue for at least another year. So what does that mean for us? How does this massive ball of fire affect our modern world? And what can we expect as it continues to blaze with energy? Stay tuned as we dive into the fascinating world of the solar maximum, the science behind it, and why the sun is far more than just a bright light in the sky. Let's really dig into what's happening during this solar maximum. What exactly is a solar maximum? Think of it as the sun's stormy season, but instead of rain and wind, the sun's magnetic field goes wild. During this phase, the sun's magnetic field becomes twisted and tangled, leading to the appearance of sunspots, those dark patches you might have seen in solar images. But don't be fooled by their appearance. These sunspots are cooler areas, but they are where all the solar action begins. When the sun's magnetic field lines cross or tangle too much, they snap, releasing massive bursts of energy called solar flares. These flares are so powerful, they can shoot out waves of radiation and particles toward Earth at incredible speeds. And when those waves hit us, they can have a very real impact. How do scientists know this is happening? NASA and NOAA are constantly monitoring the sun with specialized satellites and observatories, watching for these sunspots and solar flares. The latest data shows that we are smack in the middle of a solar maximum. Scientists measure the sun's activity by counting sunspots and tracking solar flare intensity, and right now, they're seeing an uptick in both. This heightened solar activity is all part of the sun's 11-year cycle, which shifts from quiet to chaotic. But don't worry, we're not talking about apocalyptic events. These are natural cycles that have been happening for millions of years, and they're crucial for understanding the sun's behavior, and by extension, the environment in space around Earth. What makes this solar maximum particularly interesting is that it's a little stronger than some scientists predicted. We're seeing more sunspots and stronger solar flares than expected, and that means the sun's magnetic field is even more twisted and dynamic than usual. But what does that mean for us? Let's talk about how this solar maximum affects you and me. When solar flares or coronal mass ejections, giant bubbles of solar plasma reach Earth, they can disturb our planet's magnetic field, creating geomagnetic storms. These storms can have a few different effects. In extreme cases, a powerful solar storm can overload power grids, leading to blackouts. Solar flares can mess with the electronics on satellites, causing communication and navigation issues. Think GPS not working or your phone signal suddenly dropping. On the bright side, these solar storms can also trigger stunning displays of auroras, those glowing, colorful lights in the sky, also known as the northern and southern lights. So while the solar maximum brings some risks, it also delivers one of nature's most beautiful shows. And who doesn't love the idea of gazing up at a brilliant aurora, knowing it's a direct result of our sun's activity? Now that we understand the solar maximum, let's zoom in on two key players in this cosmic drama: sunspots and solar flares. Sunspots are cooler areas on the sun's surface, but they're anything but calm. They're actually where all the action begins. Think of them as the sun's storm clouds. Sunspots form because the sun's magnetic field is all twisted up, and where these magnetic field lines get really tight and intense, sunspots appear. What's fascinating is that these sunspots can be enormous. Some of them are even larger than Earth. As they increase in number during a solar maximum, scientists keep a close eye on them because they tell us how turbulent the sun's magnetic activity is getting. Sunspots are also the birthplace of solar flares. Picture a rubber band stretched to its limit. Eventually, it snaps. That's what happens with the sun's magnetic field around sunspots. When the tension gets too high, the magnetic lines suddenly realign, and boom, a solar flare is born. Solar flares release enormous amounts of energy, equivalent to billions of nuclear bombs exploding at once. When a solar flare happens, it sends out intense bursts of radiation. Most of this radiation doesn't reach the surface of the Earth, but it can seriously disrupt our atmosphere. These flares can mess with satellite communications, knock out GPS systems, and even disrupt high-frequency radio signals. Imagine you're driving, relying on your GPS to navigate a busy city, and suddenly, no signal. That's a minor example of what solar flare can do. For instance, in 1972, a solar flare knocked out long-distance telephone communication across several U.S. states. And while technology has advanced since then, we are even more dependent on satellites and electronics today, making us more vulnerable to these space weather events. Sometimes, along with solar flares, the sun also throws out huge clouds of plasma in what's known as a coronal mass ejection, or CME. These are the real heavy hitters of solar storms. If a CME is directed toward Earth, it can cause massive geomagnetic storms. When a CME reaches Earth, it can compress our planet's magnetic field and trigger geomagnetic storms. These storms can induce electric currents in power lines, potentially overloading transformers and causing widespread blackouts. One of the most famous examples is the 1989 Quebec blackout, where a geomagnetic storm caused a province-wide power outage. But CME don't just wreak havoc, they also create spectacular auroras. The particles from these solar storms interact with our atmosphere, lighting up the skies in vibrant greens, pinks, and purples. So while there's risk involved, there's also beauty in these cosmic phenomena. The more sunspots and solar flares we see, the more likely it is that one of these solar storms will hit Earth. That's why scientists are so interested in studying the solar maximum. They're not just observing for the sake of science. They're using this data to predict space weather and protect our technology. The better we understand these solar events, the better prepared we can be. Let's move beyond Earth for a moment and talk about space. During a solar maximum, the sun's increased activity doesn't just affect life down here. It poses a significant risk to astronauts and the technology we depend on in space. Imagine being an astronaut on the International Space Station, orbiting Earth as the sun throws out bursts of radiation. During a solar maximum, astronauts are at higher risk of exposure to dangerous levels of solar radiation. This can affect their health, causing radiation sickness and even increase the risk of long-term problems like cancer. That's why space agencies like NASA have strict protocols during heightened solar activity. If a strong solar storm is on the way, astronauts might have to take shelter in specific areas of the ISS that are better shielded from radiation. Then, we have satellites, those silent sentinels that orbit Earth, providing us with everything from GPS to satellite TV. During solar maximum, solar flares and coronal mass ejections can wreak havoc on these delicate instruments. You see, satellites are bombarded by charged particles from the sun, which can damage their electronics, causing them to malfunction or even fail altogether. One example of this happened in 1997, when a solar storm knocked out a major telecommunications satellite, causing issues with TV signals, credit card transactions, and even pagers back when we still used those. Today, we rely on satellites even more, and a similar event could have widespread consequences for communication and navigation systems. How do scientists protect against this? NASA, NOAA, and other space agencies monitor the sun's activity closely, tracking sunspots and solar flares in real time. They use this data to predict space weather and issue warnings when solar storms are coming. This allows engineers to put satellites in a kind of safe mode, where they limit non-essential functions to protect sensitive electronics from being fried by solar radiation. Engineers also build shields into satellites to protect them from these radiation blasts. It's like giving our tech in space a layer of cosmic armor. But even with these precautions, solar storms are unpredictable, and the most powerful ones can still cause damage. Let's bring it all together. We've seen how the sun, in its solar maximum, can cause a cosmic storm affecting life on Earth, and even beyond, from disrupting power grids to threatening astronauts. But it's not just about the risks, it's also about learning and preparing for the future. The solar maximum will continue for another year or so, giving us a unique opportunity to study the sun during one of its most dynamic phases. And as we prepare for future missions to the moon, Mars, and beyond, learning about solar activity becomes even more crucial. The sun, once thought to be an unchanging ball of fire, is actually a living, breathing star with a profound impact on our lives. We're all connected to this massive star in ways both visible and invisible. Whether it's powering your GPS, dazzling you with northern lights, or sending a storm that shakes up space, the sun's cycles are a cosmic reminder of our place in the universe.
If you fall in, you never come out, stretching you from head to toe. Death by black hole.
Imagine this. You're floating out in the calm, serene vastness of space, surrounded by billions of stars. Suddenly, you feel a pull, something you can't quite explain, a force stronger than anything you've ever encountered. It's not pulling you like Earth's gravity, it's pulling the very fabric of space itself. Welcome to the realm of a black hole. Black holes are among the most mysterious and fascinating objects in the universe. They form when the core of a massive star collapses under its own gravity, creating a point so dense that nothing, not even light, can escape its grasp. This boundary, known as the event horizon, marks the edge of the black hole, and once something crosses it, it's lost to the universe forever. But don't be too quick to fear them, I'd say with a smile. Black holes aren't cosmic vacuum cleaners, waiting to gobble up everything around them. In fact, they don't go around eating stars or planets unless something gets too close. For the most part, they're just out there, minding their own business. The existence of black holes was once just a theoretical concept, born from Einstein's general theory of relativity. But today, we know they are real. In fact, we've even seen one. Well, sort of. In 2019, the Event Horizon Telescope gave us the first ever image of a black hole, a supermassive one at the heart of a galaxy far, far away. And let me tell you, it's not just a hole in space, it's a doorway to some of the strangest physics we've ever encountered. You're probably thinking, how can we see something that doesn't let light escape? Ah, that's where things get interesting. We don't see the black hole itself, we see the light from material swirling around it, heated up as it falls into the abyss. That glow gives us a shadow of the black hole, a cosmic fingerprint of one of the universe's greatest mysteries. The birth of a black hole, the star that couldn't hold on. Let me take you on a journey back to the life of a star, a massive one. Imagine a cosmic giant, shining brightly for millions of years, fueled by nuclear fusion deep within its core. It's a balancing act. Gravity tries to crush it, while the energy from fusion pushes outward, keeping the star stable. But like all things in the universe, this delicate dance can't last forever. Eventually, the star runs out of fuel. It's as if it's been holding up a heavy weight for eon, and suddenly, it can't do it anymore. The outward pressure from fusion weakens, and gravity, relentless and unstoppable, takes over. Now picture this. The core collapses, shrinking to a tiny, unbelievably dense point. This collapse triggers a spectacular explosion, a supernova, a cosmic fireworks display brighter than an entire galaxy. What's left behind, though, is far more intriguing. A black hole. But let me assure you, this isn't just any kind of collapse. The core compresses into something so small and so dense that its gravity warps the very fabric of space and time. What once was a massive star, millions of kilometers across, is now a singularity, an infinitely dense point in space. Around it forms the event horizon, the ultimate boundary beyond which nothing can return. This, my friends, is the birth of a black hole, a remnant of a star that once illuminated the universe, now a cosmic enigma. What happens at the event horizon? Let's talk about something truly extraordinary. The event horizon. This is the point where everything changes. Imagine standing at the edge of a cliff, but instead of looking down at rocks or water, you're staring into the unknown, where even light itself can't escape. The event horizon is like the ultimate no-turning-back zone. It's not a physical surface you can touch, it's a boundary. If anything, whether it's a spaceship, a planet, or even a beam of light, crosses this line, it's lost forever. It's as if the universe says, that's enough, you're not coming back from here. But here's the real kicker. As you approach the event horizon, weird things start happening. Time itself begins to slow down. You see, near a black hole, gravity is so strong that it warps space-time. For an outside observer, it might look like you're frozen in time, hanging at the edge of the event horizon. But for you, time feels normal, at least until you cross the line. Once you do, well, we can only speculate what happens next. The laws of physics, as we know them, no longer apply. Inside the event horizon, gravity is so intense that space and time are twisted beyond recognition. We call this the singularity, a point of infinite density, where even our best scientific theories struggle to explain what's going on. So, standing at the event horizon is like peering over the edge of the universe itself into a place where time, space, and reality are fundamentally altered. It's a reminder that even with all our knowledge, the universe still holds mysteries we're only beginning to understand. The black hole's effect on space and time. Time dilation. Let's dive deeper into one of the most mind-bending effects of a black hole, how it plays with time itself. Imagine for a moment that you could hover near the edge of a black hole, right outside the event horizon. Time, as you know it, wouldn't tick the same way it does here on Earth. Near a black hole, time slows down, not just a little bit, dramatically. This effect is called time dilation, a phenomenon predicted by Einstein's theory of relativity. To an outside observer, you would appear to be moving slower and slower as you get closer to the black hole. In fact, if someone were watching you from a safe distance, they might never see you cross the event horizon. To them, you'd seem frozen in place, suspended in time. But for you, it's a different story. From your perspective, time feels normal. Seconds still tick by, and if you could somehow send a signal back to your friend, it would just seem like regular time to you. The closer you get to the black hole, though, the bigger the difference becomes between your time and the time outside. Now, here's where it gets even crazier. If you spend enough time near a black hole, just outside its event horizon, by the time you pull yourself back to safety, years, decades, or even centuries could have passed in the rest of the universe. It's like a one-way time machine into the future, but one you'd probably never want to use. This warping of time is one of the most fascinating aspects of black holes. It's a reminder that the universe doesn't always play by the rules we experience in our everyday lives. Near a black hole, the boundary between past, present, and future starts to blur. The biggest black holes in the universe, supermassive black holes. If you think the black holes we've talked about so far are impressive, wait until you hear about their bigger cousins, supermassive black holes. These aren't just stellar remnants. They're the giants lurking at the center of almost every galaxy in the universe, including our own Milky Way. These supermassive black holes are quite literally millions to billions of times the mass of our sun. Let that sink in for a moment. Imagine something so massive that it warps not just the space around it, but entire regions of a galaxy. One of the most famous examples is Sagittarius A, the supermassive black hole right in the heart of the Milky Way. It's about 4 million times the mass of the sun, and yet it's relatively quiet compared to some of its more active counterparts. In some galaxies, these titanic black holes are far more energetic. We call them quasars. A quasar is essentially a supermassive black hole that's actively feeding, pulling in huge amounts of gas, dust, and even stars. As this material falls in, it heats up to incredible temperatures and shoots out jets of energy so bright that they can outshine the entire galaxy they inhabit. These are some of the most powerful objects in the universe, visible from billions of light years away. But how did these black holes get so big? That's one of the great unanswered questions in astrophysics. Some scientists think they formed when galaxies first began to take shape, while others believe smaller black holes might have merged over time, growing larger and more powerful. What we do know is that these cosmic behemoths shape the galaxies around them. The gravitational pull of a supermassive black hole can influence the orbits of stars across vast distances. It's as if they're quietly orchestrating the motion of an entire galaxy, while we go about our lives on a tiny planet, completely unaware of the colossal forces at work. Black holes and future of the universe. Now that we've explored the enormity of black holes, let's take a step back and think about their place in the grand cosmic picture. Black holes aren't just strange objects floating in space. They might actually hold some clues about the distant future of the universe itself. One of the most intriguing ideas is that black holes could be the last surviving objects in the universe. You see, everything in space, stars, planets, even galaxies, will eventually fade away. Stars will burn out, and over billions or trillions of years, what we know as the universe today will look very different. But black holes, they could stick around for an extraordinarily long time. There's even a theory, thanks to the groundbreaking work of Stephen Hawking, that black holes aren't completely eternal. According to Hawking, black holes can slowly lose energy through something called Hawking radiation. Over unimaginably long periods of time, this process could cause black holes to shrink and eventually disappear entirely. This isn't something that will happen tomorrow, or even in the lifetime of our sun, but in the distant future, it's possible that black holes could evaporate completely. But before that happens, black holes will continue to shape the universe. They might grow by merging with other black holes, becoming even more massive. Or they might quietly influence the galaxies around them, slowly consuming matter that comes too close. That's a tiny window in the grand scheme of the cosmos to make that first contact. It's like trying to join a party, but you're fashionably late, and the party's been going on for ages. The hypothesis of natural filters in the universe posits that advanced extraterrestrial civilizations may have existed for a long time, but were eradicated by these natural filters. If extraterrestrial life exists, the question arises whether their forms and environments would be similar to those on Earth. This idea draws from the concept that certain conditions, whether astrophysical, biological, or societal, act as filters that limit the emergence and longevity of advanced civilizations. Possible filters include cataclysmic events, astrophysical phenomena, or self-destructive behaviors inherent to intelligent societies. If extraterrestrial life exists, its forms and environments might not necessarily resemble those on Earth. Life could evolve in diverse ways depending on the unique conditions of each planet. The variety of planetary environments and the adaptability of life make it plausible that extraterrestrial beings might have different biochemistries and physical characteristics. Rocky planets like Earth are considered ideal for supporting life due to their specific conditions. However, these planets are delicate and susceptible to various threats, and this fragility means the universe could filter out intelligent life quickly. One significant threat comes from violent stellar events such as gamma-ray bursts, which are powerful enough to sterilize planets over vast cosmic distances, potentially affecting entire galaxies. Imagine this: a huge star explodes in our galaxy, the Milky Way, sending a deadly burst of energy hurtling toward our planet. This is a gamma-ray burst, which is the biggest blast since the Big Bang. There are no signs that something bad is about to happen, and then it strikes. The radiation that is pumped up heats up the high atmosphere. Our layer of ozone heats up. Across the atmosphere, human beings burn to death from radiation 100 times the fatal dose. When the ozone layer gets thinner, temperatures rise all over the world. This makes storms, tsunamis, and hurricanes happen. Most life on the surfaces of land and water incinerates. This may sound like science fiction, But if a gamma ray burst from 100 light years away hit Earth, it could happen. Even if intelligent species manage to survive these natural occurrences, there is another risk: self-destruction. Drawing from our own experiences on Earth, the development of technology has given us the capability to alter our climate and create weapons of mass destruction. This self-destructive potential poses a serious risk for advanced civilizations. It is plausible that technologically advanced societies may have a brief existence, as evidenced by our own history. The short lifespan of advanced civilizations could be a reason why there are so few observable ones at this point in time. The possibility arises that many civilizations may have emerged, but their existence was short-lived due to self-inflicted challenges. This scarcity of long-lasting civilizations could explain the limited opportunities for communication with extraterrestrial beings. Discovering remnants of an extinct alien civilization could serve as a profound warning for humanity. If we were to find evidence of a civilization that destroyed itself through pollution or conflict, it would be akin to looking at our own potential future. This sobering realization could provide valuable lessons for us on Earth, emphasizing the importance of avoiding similar pitfalls. In our quest for understanding the cosmos, we can only hope that some advanced alien species have managed to navigate the challenges posed by the universe's potentially lethal filters, offering a glimpse of long-term survival and prosperity. If we are lucky, there may be an extraterrestrial civilization that will come to visit us in the future. Imagine making contact with aliens. Sounds cool, right? But hold on, are we assuming too much? We tend to think that aliens are just like us, but here's the twist: they're not. We might be imagining them based on what we know about life on Earth, assuming they live on planets like ours. But guess what? Most of the universe might not follow our life and planet rulebook. So could extraterrestrials even survive first contact with us and our planet? July 2019, a satellite on a test mission spotted a new alien world named GJ357d, about 31 light years away. This super-Earth is over 6 times heavier than our cozy home planet. Now, what's a super-Earth? A terrestrial planet, but bulked up with more mass. More mass means more gravity, creating a whole different vibe compared to our Earth. Imagine aliens living on a super-Earth. The gravity there could be super strong. They might not be tall, but I bet they'd be super strong. Super-Earths are just one of the many wild things the universe cooks up. Who knows what other surprises are out there? The possibilities are as vast as the cosmos itself. The universe is a vast playground, with planets of all shapes and sizes orbiting stars of various types and sizes, forming countless configurations. This diversity opens up a world of possibilities for life that is much richer and more varied than we ever imagined. However, we need to break free from the idea that extraterrestrial life will resemble us. If we're expecting beings with 2 legs like ours, we might as well abandon that notion. The truth is, life out there could be radically different. Consider this scenario. An intelligent alien species in our cosmic neighborhood wants to say hi to us. But here's the catch. If that alien evolved on a super-Earth or circled a red star instead of a yellow one, its biology could be so alien that it might never set foot or tentacle on our planet. Looking at life on Earth, it seems like it's tailor-made for our specific temperature, elements, and environment. Now, imagine an exoplanet with conditions conducive to life. It could still host life forms vastly different from what we're accustomed to. What if an alien world has a bit more potassium, is warmer than our average Earth, or has a thicker atmosphere? Each of these subtle differences could create an entirely distinct ecosystem. So, the big question is, can an alien organism truly adapt to our ecosystem when it lands on Earth? It's a cosmic mystery waiting to unfold. Venus is nearly identical to Earth in size, making it one of our most similar neighbors in the solar system. With a mean radius of about 3,760 miles or 6,052 kilometers, it's approximately 95% the size of Earth. Its mass is about 81.5% that of Earth. This similarity in mass and size means that Venus also has a comparable density to Earth, approximately 5.24 grams per cubic centimeter, implying a similar rock-iron composition. Venus and Earth have a comparable structure, a central iron core surrounded by a rocky mantle and a thin crust. The core of Venus, while not as well understood as that of Earth, is believed to be partially liquid, similar to Earth's. This iron core is estimated to be about 2,000 miles or 3,200 kilometers in diameter. Above the core lies Venus's mantle, composed of silicate rock that extends up to approximately 1,550 miles from the planet's center. This is overlaid by a thin crust, estimated to be 6 to 12 miles thick. The rotation of Venus is a unique characteristic among the planets of our solar system. Unlike most other planets, which spin on their axis in the same direction that they orbit the sun, Venus rotates in the opposite direction. This is a phenomenon that isn't yet fully understood by scientists, but some believe it may be due to a massive collision with a celestial body in the past, which altered the planet's rotational dynamics. Venus rotates extremely slowly, with a sidereal day, a full rotation on its axis, taking 243 Earth days, the slowest rotation of any planet in the solar system. This slow rotation contributes to the planet's lack of a significant magnetic field. Another quirk of Venus's rotation is that a solar day on Venus, the time from one sunrise to the next, is shorter than its sidereal day due to its retrograde rotation and orbit around the sun. The solar day on Venus is about 116.75 Earth days. The planet's year, the time it takes to orbit the sun, is about 225 Earth days, which is shorter than its sidereal day. This makes Venus one of the few planets where a day is longer than a year. The surface gravity on Venus is about 90% of the surface gravity on Earth. This means that if you were able to stand on Venus, you would feel slightly lighter than on Earth. However, the extreme atmospheric pressure and temperature would make it impossible for humans to survive without protection. Venus's surface appears to be geologically young, with a relatively low number of craters indicating a surface age between 300 million and 600 million years old. Scientists believe that Venus undergoes a cyclical process where heat from the planet's interior causes the surface to be repaved in a global resurfacing event. There is strong evidence of widespread volcanic activity on Venus. Thousands of volcanoes dot its surface, ranging from less than a mile in diameter to over 150 miles or 240 kilometers. The planet has far more volcanoes than any other in our solar system. However, there's currently no definitive evidence that these volcanoes are still active, although recent studies suggest that some may have erupted within the last few million years. Despite the apparent geological activity, Venus doesn't experience significant tectonic activity like Earth. While Venus does have mountain ranges and rift valleys similar to those seen in tectonically active regions on Earth, it lacks the kind of large, distinct tectonic plates seen on our home planet. This might be due to the planet's slow rotation, which limits the Coriolis effect necessary to drive large-scale tectonic activity. Venus's atmosphere is one of its most distinctive and intriguing characteristics. The atmosphere is primarily composed of carbon dioxide, 96.5%, with most of the remainder being nitrogen. However, there are also traces of other gases, such as sulfur dioxide, water vapor, carbon monoxide, argon, and helium. This composition is vastly different from Earth's nitrogen-oxygen atmosphere, making Venus's air toxic to humans and most known forms of life. The atmosphere of Venus is arranged in several layers. The troposphere, extending from the surface to about 40 miles up, the mesosphere stretching from the top of the troposphere to about 56 miles high, and the thermosphere, which reaches up to 125 miles above the planet's surface. Above this, there's a transitional region called the exosphere that merges with the void of space. The high concentration of carbon dioxide in Venus's atmosphere creates a strong greenhouse effect, trapping heat and making it the hottest planet in the solar system, even hotter than Mercury, which is closer to the sun. The greenhouse gases in the atmosphere absorb heat energy radiated from the sun, preventing it from escaping back into space. This results in surface temperatures averaging around 467 degrees Celsius, which is hot enough to melt lead. There's very little temperature variation between day and night or between the equator and the poles, due to the thick atmosphere's efficient heat distribution. This results in a virtually constant, furnace-like temperature all over the planet's surface. The atmospheric pressure on Venus is enormous, approximately 92 times greater than Earth's at sea level. This is equivalent to the pressure experienced 0.62 miles deep in Earth's oceans. A human exposed to such pressure without protection would be crushed. Despite this, high up in Venus's atmosphere, approximately 31 miles above the surface, the pressure and temperature conditions are similar to those on Earth's surface. Venus's atmosphere is perpetually cloaked in thick, opaque clouds that cover the entire planet. These clouds reflect about 75% of the sunlight that reaches Venus back into space, which is why Venus is so bright and easily visible from Earth. The winds in Venus's upper atmosphere are incredibly fast, reaching speeds up to 450 miles per hour, much faster than the strongest hurricane winds on Earth. These winds move in a phenomenon known as superrotation, where the atmosphere rotates much faster than the planet's surface. Near the surface, however, winds are much slower, typically less than a few miles per hour. Venus boasts the highest mountain in the solar system, Maxwell Montes, rising 20 kilometers, about 12 miles above Venus's mean surface level. The planet's surface is also marked by numerous impact craters, extensive lava flows, and unique surface features like coronae, circular structures caused by the upwelling of hot material from the mantle and arachnoids, circular structures with a complex pattern of fractures. Due to Venus's slow rotation and dense atmosphere, the planet doesn't experience significant seismic activity like Earth. However, recent studies suggest that Venus may still be geologically active. Venus has been a target of interest since the dawn of space exploration. The Soviet Union's Venera and Vega missions, NASA's Pioneer Venus, and the European Space Agency's Venus Express have all contributed significantly to our understanding of the planet. The Venera program achieved many firsts, including the first human-made device to enter the atmosphere of another planet, and the first successful landing on another planet. These missions provided valuable data on Venus's atmosphere and surface. More recently, NASA's Magellan orbiter mapped almost the entire surface of Venus using radar to penetrate the thick cloud cover. This mission revealed details about Venus's surface features and geology. Despite the challenges posed by Venus's harsh conditions, scientists are interested in further exploring the planet. NASA's planned Veritas and Da Vinci Plus missions aim to study Venus's geologic history and atmospheric conditions, providing insights into whether Venus might have once harbored liquid water or even life. Meanwhile, the European Space Agency's Envision mission will focus on understanding why Venus and Earth took such different evolutionary paths. Japan's Akatsuki mission is currently studying Venus's atmosphere and weather patterns. Venus, our neighboring planet, is an intriguing world of extremes. Its harsh environment poses significant challenges to exploration, yet its similarity to Earth in size and composition, along with hints of potential past water and geologic activity, keep our curiosity alive. As we prepare for new missions to Venus, we stand on the brink of major discoveries that could reshape our understanding of the solar system and our place in it. As a reflection on our own planet's potential future, Venus serves as both a warning and an opportunity for scientific discovery. Our solar system is a harsh environment. Volcanoes are destructive everywhere, from the ice volcanoes of Saturn's moon, Enceladus, to the immense lava fields of Jupiter's moon, Io, to our own planet Earth. It is truly true that we would not be here if there were no volcanoes. Volcanoes influence and alter our climate. Volcanoes are both the creators and destroyers of existence. Today's spacecraft and observatories have revealed volcanoes on planets we once believed to be dead. The discovery of volcanoes on an object smaller than the moon was a major surprise. If there are volcanoes on other worlds, could there also be life? Volcanoes are among the most potent natural occurrences on Earth. They create new land, destroy the old. They emit gases that alter the atmosphere we breathe. Deep in our oceans, volcanic heat fuels bizarre new forms of life. Volcanoes help sustain life on Earth. Now we look for signs of life on other planets. We understand that life requires water. We are aware that it requires energy, and this is where volcanoes come in, as they generate tremendous quantities of energy. If we locate volcanoes on other planets, we may discover life. The search begins with this planet, which orbits the Earth closest. Venus, a planet that closely resembles our own. Venus and Earth have similar masses. Earth and Venus were very similar 3 billion years ago, with new land, new oceans, and an atmosphere. Both planets was conducive to life. On Venus, however, something went awry. Something caused the history of Venus to diverge drastically from that of Earth. Venus took a definite turn to the dark side a long time ago. Venus is hell, our malevolent twin planet. Today, the surface of Venus is like a furnace. The surface is 900 degrees Fahrenheit hot. It is actually heated enough to melt some metals, so you have no chance. Venus is a greenhouse world. Its atmosphere contains a high concentration of carbon dioxide. It absorbs solar heat like a blanket. Actual images of Venus's surface reveal a desolate, extremely hot desolation. The planet was annihilated by dense CO2 atmosphere. The CO2 was produced by volcanoes. Spacecraft in orbit provided the initial clues. Radar broke through Venus's thick clouds and showed volcanic formations all over the planet. These formations look a lot like the shield volcanoes on Earth. Round and flat, shield volcanoes derive their name from their shape. These volcanoes ooze, but they ooze for thousands of years. Once we were able to map the entire surface of Venus using cloud-penetrating radar, we began to examine its landforms and discovered that many of them were quite familiar. In particular, we observed enormous shield volcanoes that resembled the shield volcanoes in Hawaii. The radar images of Venus were identical to those of Hawaii's shield volcanoes. In the past, Venus was home to volcanoes. We were astounded to see a picture of Venus for the first time. We discovered a cratered volcanic surface. There are at least 1,000 large volcanoes and possibly tens or hundreds of thousands of lesser ones. Lava plains cover 3/4 of Venus's surface, evidence of an ancient catastrophe. This could have been a home for life. It was instead consumed by flames. Numerous trillions of tons of carbon dioxide were expelled by Venus's volcanoes into the planet's atmosphere. The temperature rose dramatically. The oceans evaporated. On Earth, carbon dioxide is able to absorb into the rocks. It can be absorbed by the ocean. On Venus, however, there is no water, and the temperature is so high that carbon dioxide cannot even combine with the minerals. Volcanoes released carbon dioxide into the atmosphere eons ago, and as time passed, fewer and fewer methods existed to remove it from the atmosphere. Volcanoes sanitized the entire planet if Venus ever supported life. Earth is the only known planet with life. That may alter. This is the gas giant Jupiter, with its moons believed to be frozen and lifeless. A mystery surfaces as a cloud hovering over a cold and lifeless world upon closer inspection. On Venus, volcanoes transformed a planet similar to Earth into a hyperheated inferno. Volcanoes on a planet similar to Earth were not a surprise, but the discovery of volcanoes on the moon was an astonishment. In March 1979, the Voyager 1 spacecraft provided us with our first up-close look at Jupiter's minuscule moon Io, a world we once believed to be frozen and lifeless. And they witnessed something odd. They observed this arc next to the moon, and it almost appeared as though there was a second moon behind it. We scratched our minds and asked, what could that be? Everyone is aware that Io is lifeless, dull, and uninteresting. And then people realized, oh my God, it's a volcanic eruption. We discovered that the area is engulfed in volcanoes. It is geologically extremely active. There are constant volcanic eruptions. And what they're erupting is a great deal of sulfur, which becomes extremely heated. And sulfur changes color as its temperature changes. It may be red, orange, yellow, or even black. As a result, these images of Io's visage resemble a pizza with various types of cheese and olives, where the small black spots are. Io is not dead. It is alive and growing. There are more than 400 active volcanoes. The largest, Pele, erupts from a gigantic lava lake. It extends approximately 400 kilometers into space. It would be an extraordinary sight if we could stand on the edge of that lava lake and observe that plume shooting off into the void of space. Pele's eruptions are so massive due to Io's diminutive size. There is nothing holding the lava back, as there is virtually no atmosphere and little gravity. These enormous eruptions make Earth's volcanoes resemble fireworks. How can a moon so small be so volcanic? The answer is Jupiter. Similar to how the moon raises the tides in Earth's oceans, Jupiter raises solid rock tides on Io. The orbit of Io around Jupiter is not circular. Sometimes it's closer, sometimes farther away. Jupiter exerts a gravitational force on Io. Jupiter's gravity stretches and squeezes Io. In every 2-day orbit, the ground rises and falls by nearly 300 feet. This pummeling generates extreme heat and enormous pressure. Wherever there are weak spots in the crust, lava erupts. Volcanism is therefore planet-scale. In contrast to Earth, where certain portions are active around the plates or in weak areas, this is an entire moon that's one active hotspot. Io is the most volcanism-active planet in the solar system as a result of the immense power of gravity. Volcanic activity on Io has taught us something new. It taught us that internal energy sources can drive volcanism in a manner distinct from that on Earth. Io is a lava world that is extremely hot and violent. It is difficult to conceive of anything surviving there. We have discovered strange eruptions on numerous planets and moons, but so far, the only world where volcanoes are linked to life is ours, or so we thought. This is Europa. It orbits Jupiter at a distance of nearly 500 million miles from the Sun and is a 2,000-mile wide sphere of ice. From afar, its surface appears to be polished. Up close, it's a different story. Europa is pummeled by Jupiter's immense gravity, just like its companion Io. The surface rises and bends, forming ridges and deep fissures. When we first obtained close-up images of Jupiter's moon Europa, they seemed vaguely familiar, and it turns out that they resemble Arctic ice flows.
Возникли сложности с выводом средств с брокерского счета или онлайн-платформы. Мы предлагаем юридическую консультацию, чтобы помочь вам разобраться, какие шаги возможны по закону. Консультация бесплатна. Мы работаем официально по письменному договору. Оплата услуг производится только после вашего согласия. Оставьте заявку на сайте. Это займет всего пару минут. Получите правовое заключение и список возможных действий именно для вашей ситуации.
To believe that there is a boundary between a hot core and a liquid water ocean. Underwater eruptions on Earth are surrounded by life. The same may occur on Europa. Here, the darkness is complete. The pressure, a crushing 2,000 Earth atmospheres. A harsh environment, but perhaps a cradle for life. If there is evidence of life on Earth, why not Europa? An energy source, volcanic activity, a universal solvent, liquid water, and a complex hydrocarbon chemistry are all present. Life would be difficult, but not impossible on Europa. There is life at every extreme on Earth, including searing heat, crushing pressure, and absolute darkness. Life on Europa may resemble our own in unanticipated ways. If life exists beneath Europa's ice, it would be aquatic, but without eyes, because there is no significant light. Organisms that essentially feed off the energy of the volcano would most likely utilize sonar to make sense of their surroundings. Volcanoes on Europa could be the genesis of new life. It is even conceivable that Europa is typical, that this is the norm for planets with life. Earth may represent an exception. Consider that Europa could serve as a model for the billions of moons in the universe with liquid oceans. So, all of a sudden, our horizons have expanded several billion times by looking at the moons of Jupiter. Our solar system is home to more than 170 moons. Multiply this by the size of the universe, and that's a lot of potential habitats for life. Only liquid water and a source of energy are required. Potentially, both are provided by volcanoes, and they are ubiquitous. This is Saturn, twice as far from the sun as Jupiter. However, it also has volcanic moons, and similar to Europa, these moons could support life. Saturn is one of the odd planets in our solar system, with a 600,000-mile-wide ring system, an astounding 62 moons, and one with a secret. Enceladus is one of the lesser and more distant moons of Saturn, and it's been known for a long time that it's covered in ice due to its extremely brilliant and reflective surface. However, when the Cassini spacecraft visited the planet, it made a remarkable discovery. Not on the planet itself, but on Enceladus did the Cassini probe disclose a remarkable discovery. A massive plume, backlit by the sun and erupting into space, is conclusive evidence of volcanic activity. Cassini's sensors zoom in on the south pole of the moon to capture these enormous craters scarring its surface. At the south pole of Enceladus, there are extraordinarily large fissures, which open and close as Enceladus orbits Saturn due to the tides. Now, these fissures are enormous. They extend for hundreds of kilometers. And when they begin to open, you would see a large crevasse opening at approximately 100 miles per hour along its length. It'd be incredibly spectacular. Huge gravitational forces cause the surface to open and contract with incredible velocity. This helps produce the heat necessary to dissolve ice and form oceans beneath the surface. The conditions of the water beneath the surface of Enceladus are ideal for life. It is at the ideal temperature. It would be beneficial for life. Liquid water would be just like seawater here on Earth. And the chemistry of the water we observe erupting from these fissures suggests that it contains salt. It contains organic matter as well. Therefore, we have identified a location in the solar system where there is a strong possibility that there is life right now. In the ice particles, Cassini has detected complex carbon molecules. In conjunction with liquid water, they suggest that perhaps life could exist deep within this mysterious moon. Enceladus is possibly not alone. Another of Saturn's moons might also harbor life. Titan, one of the largest moons in our solar system, the only moon with a thick atmosphere, a frozen world, ice as hard as rock, lakes of liquid methane. Yet, we may also discover evidence of volcanoes and the tantalizing possibility of extraterrestrial life on this planet. Volcanoes are one of the most destructive forces in the universe, as evidenced by Io's raging conflagration and Triton's ice and nitrogen explosions. Even on Saturn's enigmatic moon Titan, however, destruction can lead to the prospect of life. It has a diameter of 3,000 miles, making it larger than Mercury. It has the thickest atmosphere of any moon in our solar system. There is weather, including cyclones, winds, rain, and even lakes, but the temperature is so low that liquid methane replaces water, and it's loaded with essential compounds for life. Titan has proven to be one of the most fascinating locations in the solar system. It's an active world. It is the only moon with a dense atmosphere, an atmosphere very similar to that of Earth due to the presence of nitrogen, and as it turns out, organic molecules. High in Titan's atmosphere, methane gas reacts with sunlight to produce compounds essential to life. But if sunlight consistently converts methane into organic compounds, why does methane not run out? Methane is abundant in the atmosphere, but we know that it is quickly eliminated by sunlight, so it shouldn't be there. There must exist a source of methane. Something on Titan emits methane in a continuous stream. Cassini has spotted what appears to be a crater. Infrared cameras disclose that the crater is surrounded by various types of materials. Scientists believe the green areas may be volcanic, possibly plains of lava ejected from Titan's interior. On Titan, the boiling liquid emitted by volcanoes could be either ammonia or water. Methane and ethane are emitted by Titan's volcanoes, and this is likely the cause of the planet's extremely dense cloud cover and orange atmosphere. This atmosphere likely originated from the outgassing of Titan's volcanoes. Even on a globe as frigid as Titan, volcanoes require heat. On Titan, there are two sources of heat. Radioactive substances heat the interior, and Saturn's enormous gravity caresses the moon, similar to Enceladus. These two forces produce sufficient heat to transform ice into water and liquid methane into gas. Could volcanoes on Titan give life a chance to survive here? The chemical reactions necessary for life as we know it require an atmosphere, a solid surface, liquid water, and heat. Volcanoes could provide everything on Titan. If life does exist on Titan, it would be truly alien. It would breathe hydrogen instead of oxygen, and possibly swim through methane reservoirs at 300 degrees below zero. There may be oceans of ethane. Possibly, there are tidal pools, as well as volcanic and hydrothermal activity. Perhaps volcanic heat could produce enough energy to support life on Titan. That's a speculation, but it can't be ruled out. However, we may not need to travel so far to discover signs of life. We may discover it on Mars, a volcanism-rich world much closer to home. Volcanoes are ubiquitous throughout the solar system. Planets such as Io, Titan, and Triton are intricate, volatile, and violent. Once, we believed that Earth was the only planet with both volcanoes and life. Now, we find volcanoes everywhere, but alien life has yet to be discovered. Volcanoes exemplify the absolute force of creation and destruction. They go hand in hand. It is literally true that if there weren't volcanoes here, we would not be here either. Volcanic cauldrons are the birthplace of life. Volcanoes create new landscapes, seed the atmosphere with complex chemicals, replace the old with the new. If volcanoes are linked to the processes of life, where is life on other planets? Perhaps the origin of the answer lies in ancient times, when the solar system was immature on a planet similar to our own. This is the planet Mars. 3 billion years ago, volcanoes were active. The greatest volcano in the solar system still stands. The cliffs leading up to it are greater than 6 miles in height. Even Mount Everest would be comfortable in their shadow. This is the formidable Olympus Mons. It covers an area the size of Arizona. Its crater alone is 53 miles wide. A structure of this magnitude takes millions of years to construct, a period of time that volcanoes on Earth never have. The Earth's crust is constantly in motion. In the depths of the Earth, a solitary hotspot forces magma to the surface, creating a new volcanic island. While the hot point remains stationary, the surface is in motion. The new island moves away from the hot location and is replaced by a new volcanic island. Mars is different. The crust is locked solid. On Mars, there is simply no tectonic activity. The crust is one big solid plate, and so if there's a hot spot, it just sits there and builds and builds and builds. And you get a larger and bigger volcano. Therefore, Olympus Mons is so enormous. Today, Olympus Mons is an icy remnant of a distant, warmer era. Olympus, an extinct volcano on a fading planet, is now a veritable colossus due to Mars's diminished atmosphere. However, the ancient volcanic terrain of Mars could one day support life. The evidence is readily available on Earth. Volcanoes on Hawaii have formed enigmatic tunnels known as lava tubes, which are formed when rivers of molten rock rush into the ocean. Lava tunnels are formed when there is an underground river of basaltic lava, magma, and molten rock at 2,000 degrees Fahrenheit. Imagine it as an icy river with a crust of ice forming on the surface. It's the same, except here, the crust is solid rock and the river continues to flow beneath, creating this cave, this lava conduit. Recent images imply that Mars volcanoes may have also created lava tubes. Any rocky planet with basaltic volcanism will likely contain lava pipelines. Now, after possibly millions of years of inactivity, these lava tunnels could revive life on the red planet. This existence will be our own. Radiation will be one of the obstacles that future humans will face when attempting to live on Mars. And especially during solar cyclones, the incoming cosmic rays can be lethal. The tunnels and caverns of Mars's extinct volcanoes could one day serve as an ideal home, retaining air and shielding us from harmful radiation. A long-dead volcano could help fill a world with new light. Volcanoes are capable of both destruction and creation. The sun has been a friend to Earth for more than 4 billion years, warming and feeding it. Sadly, the thing that gives us life will probably be what kills our planet in the end. The sun and the Earth are connected in a special way. The Earth is a certain size, has life on it, and has seas. And these things are all affected by the sun. The sun is the reason why there is life on Earth, and it will also be the reason why it will end. When our solar mother really turns up the heat, Earth's bond with the sun will start to break down. Because it burns hydrogen into helium, the sun gets hotter. One helium atom is made up of 4 hydrogen atoms. That means that there are bits of fuel moving around inside the sun. And because of this process, the sun has to get hotter and brighter to stay up. As the core of the sun gets hotter, the upper part will get bigger and turn red. When you build a campfire, you put a lot of wood in it. When enough logs are burned, the whole thing falls down, sending out a huge burst of sparks and making the fire much brighter. In a way, because the sun is currently burning hydrogen into helium, and you could say that helium is the ash of that process. And then, as the sun collapses enough, the ash relights and the helium burns into carbon, and then things really heat up. At this point, the sun will grow bigger and bigger until it becomes a red giant and burns up most complicated life on Earth. When the sun turns into a red giant, it will grow to be 30 times bigger than it is now. This means that the sun's surface will be beyond Mercury's orbit. The sun will shine brighter by about 1,000 times. That's gonna make the Earth so hot that the outer crust, the rocks, the soil part of the Earth will melt. The whole planet would be a ball of glowing fire. The sun will cook the planets closer to it, and even though it will turn red and get cooler, the Earth will get much hotter. Just leave the Earth a burnt cinder like a charcoal briquette. So that would be bad for all life on Earth. And it's not clear what will happen to the Earth. As a red giant, the sun's size will change before it collapsing to become a white dwarf. The sun, that was huge, suddenly becomes a sun that's very small and extremely dense, only about the size of the Earth, sitting down there at the center of our solar system, very much fainter than it used to be. Then everything starts to cool down, and since that object is no longer making energy, it too starts to cool down. The last thing that will happen to the solar system is that it will cool down and freeze. Before the sun turns Earth into a snowball, people will probably move to another world or die out. But the sun could dry up our world a lot faster. If the sun doesn't kill us during the red giant phase, it could kill us sooner if it gets bright enough to dry up the seas. Water is an important part of life, so if the Earth loses all of its water, that's another reason why life might go extinct, and it would again be the sun's fault. There might be ways for Earth to get more time. As the sun gets bigger, it also starts to lose mass, much faster than it does now. And of course, if it's getting less massive, it has less of a hold on the Earth. The Earth's orbit will get bigger as it moves farther away. So it's kind of a race between the growing sun and the rising heat from the sun and the Earth, which is actually moving away from that fire that's getting too hot. Even if our world doesn't get cooked or frozen by the sun, its future looks more and more bleak. In the far future, the Earth and the rest of the universe may have to deal with the biggest monster in the cosmos. No one thinks that the most dangerous enemy of Earth is hiding among the stars. The dark bad guy will tear the universe apart. Even galaxies will break apart. The stars and planets will fall apart. The Big Rip is the name given to the end of the world. When it starts, it won't stop until all of the atoms and nuclei in the universe aren't chopped up. The Big Rip is really the end of everything. A sad idea about what will happen to the universe in the end. We used to think that the universe, which is currently expanding, can reach a point of maximum expansion. The idea behind the Big Rip is that the growth will not only keep going and speed up, but will also tear everything apart as it goes. And there is something like a vacuum pulling everything outward. A strange thing called dark energy might be to blame. Probably the most important thing for cosmologists to do right now is to figure out what dark energy is. Dark energy is called dark because you can't see it. We can tell what it is because of the way it changes the way the universe's gravity works. You can only start to see the effects of dark energy when you look at its qualities on cosmological length scales that are billions of light years long. It causes things to be pushed farther away from each other and contributes to the expansion of the universe. In the 1920s, Edwin Hubble, after whom the Hubble telescope is called, was the first person to notice that the universe is getting bigger. But it wasn't until 1998 that a top team of scientists measured that this growth is speeding up like a train out of control. As the universe gets bigger, every other galaxy moves away from us. In normal growth, the size of each galaxy stays the same. But if the universe is expanding very quickly, then each galaxy can also grow. Scientists say that the Big Rip is the end of the universe. They have even made a countdown to the end of the world. 1 billion years to pull apart clusters of galaxies, then hundreds of millions of years to pull apart galaxies themselves. And then, to get to the size of the solar system, we're talking about hundreds of thousands of years. Then, it will take less than an hour to tear the Earth apart. It's kind of cool to imagine what that would look like. If we are in protective capsule watching things happen, we would see the swallow of darkness that starts coming towards us. At that point, we would no longer be able to see any stars. The Earth's layers would be peeled off and thrown away, one by one. Everything in us, including the molecules that hold us together, would be torn apart, and every atom that makes up your body would fly away to infinity within a very short time. But one thing is certain. Something will terminate Earth and probably the entire universe. Once and for all, it's only a matter of time. It's useful to sometimes think about how fragile our life is here on Earth. That maybe we won't be here for all of time. Maybe there's a hope, but the way it looks, the universe just ends. And that's it. A supernova is the largest eruption ever observed by humans. Each detonation is the incredibly brilliant and incredibly powerful outburst of a star. One variety of supernova is caused by a dying massive star's last effort. This occurs when a star with at least 5 times the mass of the Sun explodes with a tremendous explosion. Massive stars consume vast quantities of nuclear fuel in their centers, or cores. This generates enormous amounts of energy, causing the center to become extremely heated. Pressure is produced by heat, and the pressure produced by a star's nuclear combustion prevents the star from collapsing. A star maintains equilibrium between 2 opposing forces. Gravity attempts to compress the star into the smallest, most compact spheroid possible. However, the burning of nuclear fuel in the star's interior creates a significant outward pressure. This outward thrust resists gravity's inward compression. An enormous star cools down when it runs out of propellant. This results in a decrease in pressure. Gravity triumphs and the star collapses abruptly. Imagine something with a mass 1 million times that of the Earth disintegrating in 15 seconds. The collapse occurs so rapidly that it generates immense shock waves that cause the star's outer region to erupt. Typically, a dense nucleus and an expanding cloud of hot gas termed a nebula are left